I'm Zach, and we had problem number 8, which is giving us this circuit area and telling us that we need to find the potential across and the charge built across of each of these capacitors. So here's our voltage incoming here, and we have these 3 capacitors and this capacitor here. So because these 3 capacitors up top, which we labeled 1, 2, and 3, and this one's 4, are in parallel, what we can do is then treat them as the total capacitance of that, and we can do that right over here. So we have then the capacitance of the 3 of those comes up to be 200, and then the capacitance down here is 75 in that 4th capacitor.
Alright, and because they're in series, we can say that they're going to have the same charge. So our formula is going to be V equals Q over this capacitance plus Q over this capacitance. Plug in those numbers, 75 times 10 to the negative 9th and 200 times 10 to the negative 9th. It gives us our charge of 6.4 times 10 to the negative 7. And that charge is the charge in this capacitor, number 4, and it's the total charge in these other 3 capacitors. Look it up here. No, we'll go up here. So what am I doing? So our 4th voltage is going to be equal to the Q that we just found out, plus or divided by the C, which we already have. So that's going to be 6.4 times 10 to the negative 7 divided by 75 nanofarads, and that's going to give us our voltage of 8.727. And for the other 3, because we know that they're in parallel, they're all going to have the same voltage, and that voltage plus this voltage has to equal our starting voltage of 12. So V1 equals V2 equals V3 equals 12 times V4, which is 8.7. So that's going to give us our other 3 voltages equal 3.27 volts. And then coming down here, we know that charge is just equal to capacitance times potential. So for Q1, we have our capacitance, this is 25 nanofarads, times our voltage, and it's going to give us a charge of 8.175 times 10 to the negative 8. And just repeating that with our 50 nanofarad capacitor and 125 gets us these charges, and that's the answer.